Okay, so this is my first, I guess, tutorial on the Zybo, and I'm basing it on Digilent provides a really nice tutorial for their board. Digilent provides a really nice tutorial for their board called the Zybo Z7, which is going to be the subject of a number of stuff I'm going to be doing. What I did is I went through it and went step by step by step by step to demonstrate to myself that this board was in fact working. So let's talk about it, and then I can show you some stuff. The first thing you got to do is start up Vivaldo. Now, Vivaldo, if you don't have it downloaded, you can, if you have a Xilinx based board, you can download it, and it's free to use most of it. Now, there is a license when you start getting into some of the programming. A lot of the boards, like the Zybo, which we're going to talk about, come with a license for a year, and if you go beyond that, I believe you can keep using the software. You don't get any updates. To continue, it's like $1,000, so it's not cheap if you want to continue after a year. But if you're using it a lot and you have the money, maybe something you want to do is to have a license for your machine. It's actually not specific to the board. I believe it's seat based, so it means whatever board you're using, you can carry on getting updated software with this license. So if you get it, you have a year. If you're still using it, you're still doing work with their processors, then you can get it. If not, no harm, no foul. But to do this, what we're doing tonight, no license required. So you start by creating a Vivaldo project, and it goes through that, as you can see. Very simple. You can call it whatever you'd like. You can put it wherever you like. I put mine under Home, my username, and Vivaldo. It is an RTL project, so it's a typical add source, create block design, generate IP. It's not one of these post-synthesis. Post means after you create the design. I/O planning project, that would probably be used more if you have one of their chips and you're designing how it's going to fit in a board. I believe that's what that's used for. You could import from a predefined, I don't know what that one is, but we're going to do an RTL. What you do is you skip over, and you're not going to add any source files here. You create your new project. Now this is important. It gives you two options. One is parts and one is boards. Since we're using the Zybo Z7, you select that board so it knows ahead of time everything. You don't have to include it. It has it. You download the board, then it knows what everything is, and you're ready to go in that regard. Then you need to create your block design, and we'll take a look at that in a minute. Your block design is actually the SDK based. You're not mapping directly in code. You create it graphically, and then it knows it can generate the design from there. Basically what you're going to do, if you create your design, you then create a wrapper around it. So basically what the VHDL or the any of the programming does is it provides sort of a wrapper to access what's generated through this block design. So the first thing here is you add the Zinc Q7 processing system. So that'll be your microprocessor. Your ARM is in there. And what's kind of cool is they have a bunch of built-in help. So you would click on run block design, and you apply some of these settings that they specify here in the tutorial. And then what you're going to do is it's going to do some things automatically for you. And the next thing is what this project's going to do is you're going to get I/O. You're going to get your you're going to get output through the GPIO, and there are two separate GPIOs you're going to use. The first one is a dual channel, so you can see that here, enable dual channel. The next thing, then you can create another one that is not going to be dual channel. And again, you're going to take advantage of their automation tool, which will interconnect everything. It knows about it. You do have to do some settings here, and they go through this. So it looks like this is 4 bits for GPIO 0. GPIO 2 is, now I'm not sure what the difference between BT and S, but this, I should also point out this uses AXI, which is kind of another way, kind of a routing, if you see, was it SPI or was it I2C, so the interconnections, and that's what AXI is. It's another type of interconnection. And then what you're going to do is you're going to, once you do this, it'll do everything. It'll set it up, connect. Oh, there's one more thing I think I missed here. Did I? Or no, it adds what it needed automatically, which is kind of nice. So there's also a little button that cleans it up so it looks nicer. The next step here is you're going to validate the design. Now, I got some warnings when I did it. Didn't seem to matter. They were just warnings. And then you can generate, you want to make sure you didn't mess up any connections, you don't get any errors. Then you can generate your HDL wrapper. That is the VHDL code, Verilog of VHDL, that is going to essentially put a wrapper around the input-output ports that we've created here. And then and this is what you're going to have to do, and this, you do this any of your Vivaldo projects, you're going to generate your bitstream. Once you have your bitstream, which is essentially the program, you're going to export your hardware and include the bitstream, include the program. This is going to give the SDK what it needs in order to work. It's going to know what it has access to, and include the appropriate libraries. If you do not do this, it's not going to know what libraries it needs, and your C code is not going to be happy. And then the next step is launching the SDK. Now let me show you that. Let's bring that up. Where is my SDK? There's my SDK. So the SDK, this is based on Eclipse, and if you're a C or Java programmer, you are probably pretty familiar with Eclipse. I know I've been using it. I do mostly Java professionally, so I've used Eclipse. I've been using Eclipse quite a bit over the last number of years. Now, you can see the program here. If you go back and look at the instructions, it'll tell you to create a new project, which is a Hello World application project. So your Hello World is basically a very bare bones program. And they do provide, you can call it whatever you like, it doesn't care. But the rest of this stuff is pretty important. The language, we're going to be using C, the processor, that's our Cortex, ARM Cortex, our hardware that we specified, standalone, and we're creating new. So it's going to create this new project. And it's pretty basic. So what they gave you here is a little bit more sophisticated code. So let's take a look at it. This is going to be our code. So our code is a basic C program. So like any C program, it's just basically you got your main and cleanup. So first of all, these are your includes. So this tells you the libraries that it needs in order to operate. Since we're using GPIO, we define that. We define our integers for data, for the buttons and the switches. We initialize. So we're telling the GPIO what it needs. We say it is, this looks like it's input. It's creating, set first channel to input and the other one. And so we're setting this to input because the GPIOs, I believe, are going to be taking, well, let's go back and look at the diagram. And that'll give us some insight. So let's let's go back to the SDK here, because I'm trying to, okay, I'm still on the SDK. So we're setting the data direction. So it is going to receive input from the buttons and the switches. That's why it's set to input. So while this is going to be a continuous loop, and if you notice, this is if you've done Arduino, you know this is kind of similar. You've got you're reading in your data, and you're going through a loop continuously until you're done. So you get your data, and then what you're going to do is you're going to write it out to the LEDs. You can get the button data, and what it's going to do with the button data is it's going to print out, and I think you can see it down here. It's going to print out the buttons that you pressed. So based on what value it has, that'll tell it which button you pressed. And button data. Okay, so it's just an integer, which is, but you can see they're looking at a binary. So 1, 2, 3. No, that's 1, 3. So 1, 2. 2 to the third, 8, and 16 to the fourth. So based on which binary value is read in from the GPIO, it knows which button it pressed. So this is really not any, and if it gets confused, if it's something else, if you press multiple buttons, and let's see if I have to reach the, see what happens when, yeah, you see that? Multiple buttons pressed. So that is basically, it's a very simple basic program. And the way they have you, then once you have it compiles, you got to program it. That is a little, they do go over that. Let's get back here. So once you have your program, first you've got to connect the Zybo to your PC. You're going to have one of those USB to micro USB. Now this is important. The jumper, there's a jumper on the Zybo. Let's see if we can look at it. So right here, let's see if we can make this bigger. This isn't a very good picture, but there is a jumper. We're going to show, and that jumper, now this is programmed, there are 3 settings, all the way to the left, middle, and right. All the way to the left is if you're booting off of the SD, which is something I want to get working. The middle is pretty much normal, if you were doing normal FPGA programming. I found that, I think that's what that's for. The one we want is all the way to the right. That's telling it, program it through here. And through the SDK. So let's go back to the SDK. SDK. Now, the SDK program, it's a little bit, this is the button here. Like facing an arrow sending stuff to the FPGA, program FPGA. That will take this program and it'll put it on the FPGA, and you can then you will have a program and you can run it as you can see, it's running. But you move the switches and it tells you about the switches. Turns on an LED. So that's very simple and basic, but it gives you a feel for the workflow. It gives you, we're in Debug. They have a debugger, and if you're familiar with Eclipse, you know the Eclipse debugger. Very simple. You can run it. And the other thing I did is I just used the USB terminal. Now, it's a little tricky. Depending on what else is on your machine, it could be USB 0, USB 1, USB 2. Sometimes you have to play around and see which one it is. Then you connect it up, and you should be able to run it. So let's see if we can go back to let's go over this a little bit more, look a little bit at we've gone through the code, go through the block design, and perhaps try recreating it, create a new project from scratch. So that's what we'll be doing. Take it from there.